All right, welcome to 52 Weeks of AWS. I'm going to be moving on to a new topic. I already wrapped up the security information for the security certification. Next up, I'm going to talk about data-driven organizations via the topic of data engineering on AWS. So I'm going to go ahead and get started here and talk about this concept here of data-driven organizations and what that really means here. So let's go ahead and get right into it. What I'll be discussing here is that things about AI and ML, also the different layers in a pipeline as well, and the key points to be aware of are the iterative nature of building out things with data engineering. So let's go ahead and get right into it in terms of the different things that we're going to talk about: data-driven decisions, data pipelines, role of the data engineer, etc. So if we get into this concept of data-driven decision making, this is really basically data science, right? Is using data to make decisions. And if we get into this quote here, through 2026, organizations will accelerate their investments in data and analytics by 45%. This is Gartner that's talking about this. So we know that there's going to be a large amount of spend in terms of this particular topic. And so some of the things to consider would be, if you looked into what that means is, how would you decide what restaurant near me serves the best Thai food? Where can I find a used child's bicycle? Which starters should I pick for fantasy football team? What kind of job should I pursue? What should I pay for this home? Like, these are all things that you would use data science to help you solve. I would say even further though, even what food you eat, where do you live in terms of what countries you live in, what region of the country do you live in? There's a lot of things that data science can help you solve. In terms of organizations as well, they also are going to need to think about things like customer transactions. For example, are they fraudulent or are they legitimate? What kind of web pages are going to have the most sales? Are patients likely to have relapse? If there's an online activity, does it represent a security issue? And should I harvest crops, etc.? These are all, organizational style decisions to make. And then in terms of what do you use to make the decisions here, you can think about, it's really like a broad term here when you talk about data analytics or AI ML. With analytics, it's using systemic analysis of a large data set to find patterns, using programming logic. With AI and ML, it's really the principles of data science that you're using that's been around for quite some time. In fact, data science has been around even in the 19th century. People have been making decisions based on data for quite some time. Like the famous one is the John Snow with cholera epidemic, where he was able to use data science to figure out that there was basically a mixture of pollution from the sewage system into the drinking water, and that was a data science decision. You didn't need a large language model to actually get that to work. Now, if you think about these two approaches here, we have the analytics approach. What are the features that best are able to predict a dog? And then if you had an AI ML approach, you could maybe say which of these images have the same features as the pictures that I've seen that were labeled as dogs. So they're slightly different approaches, and it's important to know the difference. In terms of a business example, for analytics, it could be a retail business would analyze total revenue per customer and segment the customers into categories. And that segmentation could be used for a higher level of customer service. With an AI or ML approach, you could also use different techniques like analyzing customer churn, or you could even do, let's say, some k-means clustering to discover hidden patterns in the data to retain customers. And so one of the ways to think about this is that if you had an axis where on one side here, in X, you have more valuable, and a Y, we have more difficult, you could think of at the lower left quadrant, you have descriptive, what happened. As you move up, it would be diagnostic, and then you have predictive, what will happen, and then prescriptive is how can we make something happen or prevent something from happening. So this is uh, some of the things that we're doing with ML and AI. So there's more data and fewer barriers is equal to more data-driven decisions. So you would want to increase the volume of available data, uh, and this would give you a greater opportunity for data-driven decisions. Also, there's fewer barriers to analyzing and predicting as well. Now, data science in daily life, again, we see things like shopping, which movie to listen to through, let's say, recommendation engines, or getting notifications about the pathway of some kind of delivery at your house, or even the use of credit cards outside of a traditional region, or even navigation on a phone. These are all data science based things that are happening in the real world. But just because you have more data, it doesn't always mean that there's more value to it, because there's going to be higher data costs, and there could be more unstructured data. There's also a security risk. If you have a lot of data that you're holding, it's a greater target for people to actually grab that, and then it's going to take more money to process it. In terms of thinking about data as well, data could become less valuable for decision making over time, and so it could be the most valuable if you're able to have near real time, and maybe if it's actionable, it could be within seconds. If it's reactive, that would be minutes or hours. Less valuable would be historical data. Although the one caveat here would be, potentially if you had, movie archives or, copyrighted books or something, that could be a very valuable target as well for potentially hackers or other people to target your organization and steal your intellectual property, or even claim fair use as well. These are things that I think we're struggling with currently with large language models. So the trade-offs of data-driven decisions would be, in terms of costs, should you actually invest more to go quicker, and speed, how quickly can you get an answer, and can you sacrifice accuracy for speed? And then in terms of accuracy, how accurate do you actually need to be, and should you wait for a better answer, if you're going to get a better response potentially. And some of the key takeaways would be that a data-driven organization would use data science, and analytics relies on programming and tools for this. And AI and ML can learn to make predictions from examples and data. Really, that's what AI and ML is just inferring things based on historical data, historical labeled data in many cases, or discovering patterns in the case of unsupervised machine learning. And one of the big costs is going to be the available data, coupled with a decrease in the cost of relevant technologies. So the data pipeline is something you hear quite a bit in terms of data engineering. Let's talk about that a little bit next here. So a data pipeline is really basically collecting data, then storing it and processing it, and then building something useful with the data. And you could think about working backwards to design an infrastructure. So, what do you actually need to support this? And then what is the decision you're trying to make? And then you would weigh the trade-off of cost, speed, and accuracy. And if we go into the layers of a pipeline infrastructure, again, we have ingestion, and then we have storage, processing, analysis, visualization, and then prediction and decision making. And it's possible in terms of, let's say, analysis and visualization, you stop at that point. It doesn't always mean you need to make a prediction. You could actually just analyze it, and your analysis could be, we can't make a decision because we don't know of any good move based on what we've done for an analysis. And then in terms of actions taken with data in the pipeline, you could do things like, for example, transformation of the data. So this is very common as well, as you would get some kind of data that needs to be manipulated in terms of the column name is changed, or the type of data in a row is the wrong type of data, et cetera. And you do some kind of data wrangling to make it better. And so this is a very iterative process. And obviously, the larger the data you have, the more time it's going to take. But it isn't going to be a slam dunk immediately. Once you get data, you're going to have to go through the process of software engineering. Now, in terms of a simple pipeline here, we have a developer that could potentially have some compressed CSV files that could be put into Amazon S3. You could even do some simple SQL statements on the data that's in S3. This is one of the features of Amazon S3, and then you could analyze it. So the key takeaways here are that a data pipeline would provide infrastructure for data-driven decision making. When you're designing the pipeline, you need to first start with the business problem. Otherwise, you're going to be trying to look for solutions in search of a problem, and the pipeline is going to include multiple layers, right? It'll do ingestion, storage, processing, analyzing, and a data wrangling is going to refer to how the data is acted upon in the pipeline, and also it's iterative. So what about the data engineer in a data-driven organization? So some of the big things that you would need to think about is, does the organization even have the data? So again, I think in large language models here, many of the companies are potentially trying to claim fair use, right? Because they need to have high quality cured data sets that are copyrighted. And so that might be one of the big questions that a lot of generative AI companies are asking is, well, how do I actually get access to high quality data, and where's the data stored? Is it stored in, let's say, somebody's online learning platform, or is it stored in Netflix? And can I transcribe it and turn that data into, a really rich data source? These are some of the ethical as well as technical questions for data engineering. So some of the big takeaways here are that data scientists and data engineers are often very confusing, and that a data engineer is primarily focused on infrastructure, while a data scientist would work with the data in the pipeline, but that's not necessarily always the case as well. So what are some modern data strategies here? Well, I would say a three-pronged strategy would be modernize, unify, and innovate. So in terms of modernization here, you would be moving maybe your data from an on-premise to a cloud, migrating the tools, and also building a loosely coupled pipeline. So you can use lots of different techniques in a single source of truth. So you would break down data silos, democratize access, use a data lake to run queries, etc. And then in terms of innovation, potentially moving from reactive, right, where you're looking at very old data, to proactive. Can you actually, infer decisions based on the data, and can you incorporate AI ML into making new insights? And could you take advantage of cloud services when you're doing things? And so here's a quote from a AWS enterprise strategist: being a data-driven organization means culturally treating data as a strategic asset, and then building the capabilities to use the asset, not just for big decisions, but also for everybody taking action on the front line. So some of the key takeaways are that organizations should want to become data driven because it helps you modernize. Also, if you move to the cloud, it can help you deal with some of the compute limitations. And if you're able to unify the data, you can add, a single source of truth, right? They're not going to be lots of different people looking at different dashboards. And then innovation could be looking at different ways to use that data to provide insights. So that's a good in for today, really, which is thinking about adding data in an organization and thinking about data engineering versus data science. And I think we're also going to find this in the world of generative AI. I think where maybe some of the limitations are actually not technical at all, right? We've had deep learning, we've had machine learning, we've had data science for years and years and years. And so many generative AI companies may be looking at proprietary data, and can they get away with maybe crawling a proprietary data set and then claiming afterwards fair use? And then is their strategy even a legal strategy versus a technical strategy where if they can just get their hands on that data? Like, for example, one of the ways that potentially somebody could do this is, let's say you opened up a television connection to Netflix. And then in terms of what you would do next is you would do something called analog leak. You could play the Netflix video, and you could actually use a microphone to actually listen to the audio of the movie. Then that audio would be captured as an MP4 file, and then you would use a transcribe technology like OpenAI's Whisper, take that data, and then put that into your generative AI system. Now, the question is, if you're using a movie that's copyrighted, and there's intellectual property that you don't own, if you're able to use this analog leak kind of technique to actually capture it, is illegal. And I think that's one of the things that we're seeing, is that some generative AI companies are calling this fair use, right? So if you were able to hire lots of gig workers, for example, to transcribe all of the content that's in a movie catalog, you could. There's no way to actually prevent this, right? So if motivated generative AI companies were trying to get access to the most rich intellectual property in the world, this might be one of the techniques. It's almost like, where would you rob if you were going to rob a bank? You would maybe rob Fort Knox, right? Because that's where all the gold is at. So in terms of the new world of generative AI, some generative AI companies may be targeting very rich sources of data. So then you, as a data engineer, also have to think about, what are some strategies I can do to mitigate this. And so we don't know, but I think we're really opening up some very interesting legal as well as technical problems in the world of both generative AI and also data engineering.